Okie dokie, everybody. We're on our last lesson about factoring. And you guys, the reason we factor is because we are trying to get an equation to the point where we can solve it. And we're solving quadratic equations. And all of this factoring that we've been doing has been like step one to solving a quadratic. And there's lots of ways to solve a quadratic, but factoring is a great way to do it. So I just want to show you real quick, there's another way to solve a quadratic, and that is by graphing, which we'll talk about more, but I'm going to switch screens here and go on over to Desmos to graph this. Okay, so you have it right there on your screen. Just the regular graphing calculator is great. Let me type it in. Y is equal to x squared. Down here in the keyboard, you can pick up the square. Okay, plus 3x minus 10. Now, when you graph a quadratic, it builds this shape called a parabola. Kind of looks like a U if I zoom way out. And the solutions to any equation ever are right here on the x-axis. So the solutions to this equation are going to be x equals negative 5 and x equals positive 2. And we can see that really clearly when we graph this function. But we want to have an algebraic way to solve as well, and that's where factoring comes in. So I'm going to go ahead and write these answers down over here in the margin. X is going to equal negative 5 and x is going to equal positive 2. And now let me show you how to get there by factoring. Maybe I'll draw a little. We had a parabola like so, and it hit at negative 5 and it hit at positive 2. Okay? All right, so to make the function something that can be graphed, you have to get rid of the y equals and swap it out for an equals 0. So I'm going to do that first. Take off that y equals and set this equation equal to 0. Now, here's the key point right here. The whole reason we've been factoring is because we have to factor the left side of this equation. So I'm thinking through all of the ways that we've learned to factor. GCF factoring was the first way, so that's what I'm going to check first. Is there something I can divide through 1, 3, and negative 10? The answer is no. There's no GCF. There's no number that divides into all three of those terms. Okay, the second type of factoring we practiced was difference of squares. This is not a difference of squares. Difference of squares is when you have one squared term minus another squared term. And then the third way we practice factoring was with a trinomial, which trinomial means 3 terms, and that's what we're looking at right here. This is a 3 term. So to factor a trinomial, we need to set up our product sum chart. In our product sum chart, we're looking for 2 terms that multiply for A times C. Now, this has a 1 out front. It's invisible, but it's sitting there. So 1 times negative 10 is negative 10. And our B value is 3. So in our product sum chart, we're looking for the 2 terms of A times C that add up to B. Well, not much multiplies for 10. We've got 1 times 10 or 2 times 5. If I'm trying to multiply for a negative 10, one of these values has to be negative. But I also want to add for a positive 3, so I hope you're zooming in on 2 and 5. If the 2 was negative and the 5 was positive, we would be getting that positive 3 sum. Now, because there is a 1 out front, this is a shortcut problem. I do not need to split the middle term and find the GCFs and all that stuff. Because there's a 1 out front, my 2 factors are the products that we found in the combination, x minus 2 and x plus 5. Okay, now A lot of you should be to the point where you can do this little bubble in your head. If you can do that product sum chart in your head, that is fantastic. It'll really save you a ton of time. Okay, so the factoring is done. If that was a problem, if you had a hard time right there, do not continue. You need to go back into factoring and keep practicing your trinomial factorizations, okay? If you're good with this, keep working with me. Step 3 says, set each factor equal to 0 and solve each factor for x. So here's factor number 1, x minus 2. Set it equal to 0, solve it for x. You can add 2 to both sides, and this x is equal to 2. Factor number 2 is x plus 5. Set it equal to 0, solve by subtracting, and we get x equals negative 5. Ooh, look right here. X equals 2 is where it hit the 2 on the x-axis. X equals negative 5 is where the graph hit negative 5 on the x-axis. So factoring and looking for the x-intercepts is getting us the same, graphing and looking for the x-intercepts is getting us the same solutions as factoring does. We need to be masters of both. So let's do some example problems here. A really good indicator is that you could take these over into Desmos, graph them, and confirm your answers. And that is what we're going to do. All right, let's take a look at number 1. In fact, I'm kind of looking at this whole page and noticing that all of the left sides are trinomials. So we're going to be going back to a lot of product sum charts, okay? Trinomial factorization is the most common form of factoring. All right, so get my product sum chart ready. This problem's already equal to 0 on the right side. If you want to write in a 1 out front, you can. A times C is 3 in this problem, and the B value is 4, so I'm multiplying for 3 but adding for 4. Man, it can't get much easier than that. Multiplying for 3 is just 1 times 3, and 1 plus 3 is 4. Because there's a 1 out front here, that's a shortcut problem. So I can go straight to my factors of x plus 1 and x plus 3. The factoring is done. That is quick. And if you can do this in your head, it's even quicker. So I'm on to the solving step. Set each factor equal to 0 and solve for x. So I'd subtract 1 on both sides for the first factor and get negative 1. Subtract 3 on both sides for the second factor and get negative 3. I have 2 solutions, x equals negative 1, x equals negative 3. Really, really easy way to check is to take this equation and graph it. So x squared plus 4x plus 3, I'm going to take that over to Desmos. Y equals x squared plus 4x plus 3. Looking for the x-intercepts, I've got a negative 3 and a negative 1, which confirms my factors. All right, let's pick another problem to try. How about number 5? It's another trinomial, so I know I need my product sum chart. The A value is still a 1, but 1 times 21 is 21, and my sum is negative 10. So I need 2 numbers that multiply for positive 21, but add for negative 10. And there's not a lot of things that multiply for 21. 1 times 21 and 3 times 7. So I hope it's clear for you to see at this point after all of this practice that we want to pick the 3 times 7. Now they have to multiply to make a positive but add to make a negative, so they both need to be negative. Negative 3 and negative 7 add up to negative 10. This is a shortcut problem because the coefficient is a 1 out front. So I can write this up as x minus 3 and x minus 7, and my factoring is finished. My solving is not finished, but my factoring is finished. I need to take each factor and set them equal to 0 and solve for x. So add 3 on the first one, x equals positive 3. Add 7 on the second one, x equals positive 7. It is so easy to check your work here, you would be crazy not to. Take this function and type it into Desmos to find this x-intercepts. We've got y equals x squared minus 10x plus 21. My x-intercepts are positive 3 and positive 7, just like our solve confirmed. Okay, I want to flip over because all of these front problems are shortcut trinomials. So there are different types of problems on the back. A few of them here are just GCF problems. A few of them here are difference of square problems. So I want to hit a couple highlights. Take a look at number 9. It is a minus. We can take the square root of x squared and it comes out as a whole, but we cannot take the square root of 8. That comes out as a decimal. So this is not a difference of squares problem. This is a GCF problem. Now, what can I divide both of these items by? We have a 1 out front, so there's no numeric value that I need to think about, but I can divide an x out of each of them for my variable. So my GCF here is x. X squared divided by an x leaves me with 1x. Negative 8x divided by an x, those two x's would just cancel, so I have minus 8. So here's my two factors, x and x minus 8. So if I set each factor equal to 0, it would look like this. X equals 0 and x minus 8 equals 0. This is already solved, so that was easy. This one I need to add 8 to both sides to solve, and I would get x equals positive 8. So here are my two solutions. X equals 0 and x equals positive 8. Take it to Desmos. Check your work on Desmos. So easy. We've got x squared minus 8x. And here's your two x-intercepts, 0 and positive 8. Let's do a difference of squares problem. Take a look at number 15. This is a minus sign in the middle, and there's two squared values on either side. These are perfect squares. I can take the square root of 4x squared and get 2x, and we can take the square root of 81 to get 9. So this is a difference of squares problem. In difference of squares, your factoring comes out as a pattern. One binomial has a plus, the other has a minus, and your square rooted values go into the different slots. So 2x will go into slot number 1, and 9 will go into slot number 2. So my factoring is finished, 2x plus 9 and 2x minus 9. Now I take each factor, set them equal to 0, and solve. Factor number 1, I need to minus 9 first, so I'd have 2x equals negative 9, and then divide by 2, so x is equal to negative 4.5. Factor number 2, I need to add 9 first, so 2x is equal to positive 9, and then divide by 2, so x is equal to positive 4.5. Let's check that work over here in Desmos. We have y is equal to 4x squared minus 81. Ooh, that's a really wide parabola. I'm zoomed way out, but I'd have to zoom way out to see the whole thing. But I've got one x-intercept at negative 4.5 and the other at positive 4.5, so my solutions have been confirmed. Okay, there's one more little section here on your notes, and you'll notice that the equations are just not in standard form yet. They're not equal to 0 yet. So all you have to do is move things around before you factor it, before you solve it. So let's take a look at maybe number 19. Okay, this right side is supposed to equal 0, so I need to move this 7 over. To move it, I have to subtract it. It has an x on it, so I need to line it up with the other terms that have an x. And now my right side is equal to 0. So let's clean this up. X squared didn't change. Negative 5x minus 7x is negative 12x. And negative 64 didn't change. So what's left here is a trinomial, which means I'm going to need my product sum chart. I'm very lucky because this trinomial has a coefficient of 1 out front, which is great. So I know it's going to be a bit of a shortcut problem. A times C would make negative 64, and B is negative 12. So I'm thinking of two things that multiply for negative 64, but add for negative 12. Lots of choices. 64 could be 1 times 64, 2 times 32. I don't think 3 will work. That would have a decimal in it. 4 times 16. 5 won't work. 6 won't work. 7 won't work. And then it would be 8 times 8 for our last option. Now, can you do that in your head? Because that would be awesome. Which one of these terms are going to give us a negative 12 as the sum? So play around with some negatives here. It's going to be the 4 and 6. The 4 and 16. If the 16 was negative, the sum would come out as a negative 12. This is a shortcut problem, so I've got my two factors here as x plus 4 and x minus 16. Set each factor equal to 0 and solve. On the first factor, I would subtract 4, giving me an x equals negative 4. On the second factor, I would add 16, giving me an x equals positive 16. And now I am going to take the time to check this in Desmos. I'm going to plug in where it's equal to 0. That's important, where we got it equal to 0. So we have x squared minus 12x minus 64. Checking my x-intercepts, I've got negative 4 and positive 16, which confirms my work. Whew, okay. What a unit. I hope you are feeling like an awesome, awesome master of factoring at this point. If not, please come see me. We can keep on trying. There are other ways to do this work. You do not have to do it the way that I do it. I can teach you a different method that may work better for you. But I need you to keep practicing. We've got lots of practice problems here on the page. You can also access maybe an iExcel for extra practice. But come see me if you need anything, and happy studying.